All right, this lesson is going to tie into what we learned the last lesson, talking about synthetic division. And specifically, we're going to talk about remainders today and how those tie into other things with the functions. So let's first talk about what happens when we find the remainder for x to the third power minus 3x squared plus 4. So remember, the old way we would do it would be to, when we're divided by x minus 3, we would change the sign of that 3, make that plus. We do our coefficients. We do 1. So 1x cubed minus 3x squared. Notice there is no x, so we put a 0 there for your placeholder and plus 4. Put a horizontal line. You always bring down that first number. Multiply by the outside number in the box. That's 1 times 3. Add down. Multiply. Add down. Multiply. 0 times 3 is 0. And then we add down, we get 4. And so this ends up being, that's x to the third. This is 1x squared plus 0x plus 0. And then this 4 is your remainder. So we say plus 4 over, since we're dividing by x minus 3, x minus 3. And those zeros don't really need to be there, so we just say x squared plus 4 over x minus 3. Of course, this question only wanted to know what is the remainder, right? So we only really needed that number. So if you click through the slide, you'll see just the quick visual of what to do, just what we did here. So, and again, remember, you can check it on the graph, making sure that your original division and your answer overlap, which they do in this case. But now let's look at it a different way. Instead of dividing by x minus 3 using synthetic division, just take that negative 3 and plug it into the function. So what is f of 3? So what is 3 cubed minus 3x squared plus 4? Take a moment to put that in Desmos. You can type in 3 in parentheses to the third power minus 3 times parentheses 3 squared. And of course, that's 0. And if you add 4, you get 4. You could also, since I have f of x titled for that function, you could just simply say f of 3, and you would get 4 in this case. So you get 4. What's that connection? Turns out, when you divide by a linear divisor, so like x minus a, the remainder is going to be what you get when you plug in the opposite of that. So, you know, this was x minus 3. So if I did f of 3, that's my remainder. And if it was x plus 3, then if I plug in negative 3, my remainder would be whatever I get. So that's called the remainder theorem. And we can use that to do pretty much any remainder as long as you plug in the opposite number of what you're dividing by. So let's visit it with this. We got x plus 2. What's the remainder? So of course you can do it the way we did before, which was switch the sign, bring down the 1. 1 times 2 is negative 2. Negative 3 plus negative 2 is negative 5. Negative 5 times negative 2 is positive 10. Remember, that was a 0x, so 0 plus 10 is 10. 10 times negative 2 is negative 20, and 4 plus negative 20 is negative 16. But you could also do it by just plugging it into Desmos. So if you plug in negative 2, you can watch me do that here. Negative 2 to the third power minus 3 times negative 2 squared. Plus 4. you get negative 16. That's the same thing as doing it long division or synthetic division. So if you only need the remainder, it's kind of easier just to plug it into the function and get your output without having to go through that whole process of synthetic division. It only works when you are trying to get the remainder. If you're trying to get the rest of the division, you do need to go through the whole process of synthetic division to get your full answer. So let's revisit again. You got a question, what's the remainder when f of x is divided by x plus 1? Well, let's see, x cubed minus 3x squared plus 4. So if I did f, let's see, x plus 1, so f negative 1, right? Because you got to do the opposite of that, you get 0. What about x minus 2? That'd be f of 2. You get 0 for both of those. So what is that connection? You notice they're both 0. On the graph, notice that your zeros are both a negative 1 and positive 2, which are basically the opposite of those signs. And you can click on here to get those. Well, it turns out those are both factors, right? X plus 1, x minus 2 happen to be factors of that, right? So factors. And keep in mind that that minus 2, or that x equals 2 is a double root because it has a minimum or maximum at that point. So it's a minimum there. So it's going to be a double root. So since x plus 1 is a factor because a negative 1 is a 0, and x minus 2 is a factor because 2 is a 0, it's a double root. And you both get a remainder of 0. See how that 0 of remainder and plugging in, giving you 0 as a value is that relationship there. So basically the idea is anytime you plug in and you get a remainder of 0, that divisor ends up being a factor. So how would you write that in factored form? Well, you have x plus 1, and then you have x minus 2, but since it's a double root, you have it written twice. So that ends up being x plus 1 and x minus 2 squared. So those actually mean this, those give you the same thing. You can check that in the graph. X plus 1, x minus 2 squared. And it's one thing to take my word for it, but click on this graph here and you can actually explore if it were like a multiple choice. You could put the original function in the factored form. That's not going to overlap it. That's not going to overlap it. You see, these both have the same zeros, but this 2 isn't really a double root for this one because it doesn't have the square. That third one does. You can see those both are the same thing. And that's kind of how you know graphically that those match up. So it's going to be C on that one. And then just try this one on your own. It says, which of the following is true? Suppose f of g of x equals x cubed plus x squared minus 20x. Which of the following is true? Well, let's graph it. X cubed plus x squared minus 20x. And let me make sure I type that in right. X cubed plus x squared minus 20x. So they want to know which is true. So x plus 4 is a factor because g of 4 is 0. While g of 4 is 0, that's of course true. That doesn't mean x plus 4 is a factor because x plus 4 is supposed to align with g of negative 4. So remember that you want to plug in the opposite of that. And of course, that's not the case here. So that's not going to work. So let's look at answer choice B. X minus 4 is a factor because g of negative 4 is 32. Well, again, if you look at the graph here, g of 4 is 32, g of -4, or g of 4 is 0, g of -4 is 32, but g of -4 being 32 doesn't align with the factor x minus 4. It aligns with the factor x plus 4, or the expression x plus 4. So you have to have the opposite sign. So you would say g of 4, not g of -4, when you're referring to the expression x minus 4. So about x minus 4 is not a factor because g of 4 is 0. g of 4 is 0, which means x minus 4 is a factor. All right, we know g of 4 is 0 because we just put that in here for up here, but x minus 4 is a factor because of that. But for x plus 4, that's the true one, because it's not a factor, because you get 32 when you plug in -4. So that's going to be the true statement in this case. Anyway, thanks for watching. Hopefully that's helpful for you.